There have been a variety of enhancements to Dynasty in recent years. These include improved computational efficiency, pricing analysis, diurnal curve estimation for future year models, moves integration, skim retrieval for trip-based models and activity-based model integration, incorporation of reliability measures into planning processes, and transit integration. So, in the four-step framework, Dynasty can serve as a companion model to steady assignment, and sub-area attributes can be provided to support modeling needs for different jurisdictions. There has also been some exciting progress in linking Dynasty with dynamic traffic assignment. In this case, a new DTA model called Fast Trips has been developed and is able to simulate boarding and alighting on buses at a passenger level, as well as a passenger's decision-making process of which bus stop they go to. It can also simulate their decision-making process when selecting which bus to get on, considering price, travel time, transfer time, and so forth. The bus simulation in Dynasty, therefore, is fairly realistic, capturing the time spent as a result of boarding and alighting at every stop. The driving behavior of buses also affects the service vehicular traffic, and all of this can be captured in the Dynasty simulation. One example here is a managed lane scenario with US 36 between Denver and Boulder in Colorado. The managed lane is an additional lane in the center of US 36 and is a one buffer separated lane. It goes from the I-25 expressway all the way to Boulder. It has been proposed to run bus transit, and the toll inside the lane is dynamic. This graph in the top left of this slide shows the fairly unique capability of Dynasty to display the price of the lane at various times. The x-axis is the time, and the y-axis is the toll rate, and as you can see, the toll rate fluctuates systematically throughout the day. Let's take the Sheridan location as an example. The price starts at a minimum of 25 cents and gradually increases, peaking at somewhere around 8:30 where it begins decreasing. The bottom right displays a heat diagram showing the congestion levels as colors, with red being low speed and blue being high speed. The x-axis here shows the distance, and the y-axis stands for the time. One would intuitively expect that the general purpose lane would be congested at the time when the toll rate peaks, and that the price increases in order to maintain the minimal level of service for the managed lane. If we compare the traffic conditions at the Sheridan location, we can observe this phenomenon, where congestion gradually increases and peaks around 8:30, reflecting the trend found in the toll rate graph. We can also compare the two scenarios with the two heat maps on the bottom. The left one is the no-build scenario, and the right is the $260 million build. Dynasty was able to describe the phenomenon where congestion is largely alleviated along the corridor, but not completely eliminated. There is still some traffic congestion approaching downstream I-25, although the congested area is largely reduced. This gained the attention of the Colorado Department of Transportation concerning the potential congestion in the downstream interchange between US 36 and I-25.